Visible to the naked eye and studied by Persian astronomers around 900 AD, the Andromeda Nebula was thought to be a part of the Milky Way. In fact, it was thought that all the stars in the universe were in our Milky Way galaxy. That changed in the early 1900s. In 1923, Edwin Hubble found a Cepheid variable in the nebula. The star altered the course of modern astronomy. The star goes by the name V1. Here's Edwin Hubble's image of Andromeda, which was made on a 4x5-inch glass plate and dated October 6, 1923. He originally identified 3 stars and marked each of them with an N for nova, a class of exploding star. Later, Hubble realized that the nova at the top right was actually a Cepheid variable. He crossed out the N and wrote var for variable. He added an exclamation point because he knew that this variable would allow him to calculate the distance. And indeed, once the period was measured at 31.4 days, he knew he had another galaxy. Before V1, distances to stars were measured in thousands of light years. After V1, the universe became a much bigger place. V1 was over 2.5 million light years away. Andromeda is a beautiful, barred spiral galaxy with 2 spiral arms that glow with a massive number of new stars. This is very much like our Milky Way. But it is 220,000 light years wide and contains around 1 trillion stars. That makes it a good deal larger than our galaxy. Light from this magnificent galaxy left its stars just over 2.5 million years ago. When the light that entered Hubble's telescope left Andromeda, there were no humans on Earth. While the light traveled towards Earth, we came into being. We created and lost great civilizations, and we built the telescope that caught the light when it finally reached our planet. Here we see the 100 million solar mass black hole at Andromeda's core. This is the sharpest visible light image ever made of the nucleus of an external galaxy. There is a blue glow at the center of what appears to be a double nucleus. Astronomers using the Hubble Space Telescope have identified the source of the blue light surrounding this supermassive black hole. New spectroscopic observations reveal that the blue light consists of more than 400 stars. The stars are tightly packed in a disk that is only 1 light year across. The disk is nested inside an elliptical ring of older, cooler, redder stars. When the stars are at their furthest point in their orbit, they move slower, and this gives the illusion of a second nucleus. There are 54 galaxies in the local group. Andromeda is the largest. The Milky Way is second, and Triangulum is third. All the rest are dwarf galaxies, and most of these are orbiting one or the other of the three big ones. The Milky Way has 16 satellite galaxies. Andromeda has 25 satellites, and the Triangulum galaxy might have one. The other members of the group are gravitationally not orbiting any of these three large galaxies. We'll take a good look at some of these, and then move closer to home and have a good look at some of the dwarf galaxies orbiting us. The Triangulum galaxy is the third largest member of the local group of galaxies, with a diameter of about 50,000 light-years. Triangulum is home to around 40 billion stars. That's small compared to our 600 billion and Andromeda's trillion. NG 604, a gigantic star-forming region, lies in the outer Triangulum spiral arm. This monstrous star-birth region contains more than 200 brilliant blue stars with a cloud of glowing gas some 1,300 light-years across. That's nearly 100 times the size of the Orion Nebula. By contrast, the Orion Nebula contains just 4 bright central stars. The bright stars in 604 are extremely young by astronomical standards, having formed a mere 3 million years ago. This small, irregular galaxy is one of the Milky Way's closest neighbors and is considered prototypical of the earliest fragmentary galaxies that inhabited the young universe. What's striking about NGC 6822 is its unusually high abundance of H II region emission nebula. These are visible surrounding the small galaxy, particularly towards the upper right. This is one of them. The glowing gas cloud called Hubble V has a diameter of about 200 light-years. A faint tail of nebulosity trailing off the top of the image sits opposite a dense cluster of bright stars at the bottom of the irregular-shaped nebula. IC10 is another irregular galaxy. Edwin Hubble suspected it might belong to the local group of galaxies, but its status remained uncertain for decades. Its membership in the group was finally confirmed in 1996 by direct measurements of its distance based on observations of Cepheids. The reason it took so long is that despite its closeness, the galaxy lies near the plane of the Milky Way and is therefore heavily obscured by our galaxy's interstellar matter. NGC 3109 looks like a small spiral galaxy. If it is a spiral galaxy, it would be the smallest in the local group. It is oriented edge-on from our point of view and may contain a disk and a halo. It does not appear to possess a galactic nucleus, but it does seem to contain an unusually large number of planetary nebula. Here's a satellite galaxy of NG 3109. It's a small, irregular, gumdrop-shaped dwarf galaxy. The bright foreground yellowish stars are actually in the Milky Way. Beyond them lie the stars of Sextans A, with young blue star clusters clearly visible. This map shows the closest dwarf galaxies. They are all gravitationally bound to the Milky Way, requiring billions of years to orbit it. Sagittarius dwarf is the closest. It is so close that it is slowly being ripped apart by our galaxy. Fornax is the furthest away. But the two dwarfs of the most interest can be seen in the southern night sky. They are the Large Magellanic Cloud, 160 to 170,000 light years away, and the Small Magellanic Cloud, a bit further at 200,000 light years from us. The Large Magellanic Cloud, or LMC for short, is the brightest galaxy in the sky. It contains several billions of stars, and many stars are still forming in it. The Small Magellanic Cloud, or SMC for short, contains at least several hundred million stars. Like the LMC, there is still a lot of star formation taking place within it. You may have noticed that as we went through our segment on supernova, N63A and 1987A were listed at 160,000 light years away or greater. That was further than the maximum extent of our galaxy. That put these objects outside the Milky Way. They were actually in the LMC dwarf galaxy. Here are a few more of the beautiful nebula in the LMC. This image of supernova remnant 0509-67.5 was made by combining data from two of NASA's great observatories, Hubble and the Chandra X-ray Observatory. The results show soft green-blue hues of heated material from the X-ray data surrounded by the glowing pink optical shell, which shows the ambient gas being shocked by the expanding blast wave from the supernova. Several million young stars are vying for attention in this Hubble image of a stellar breeding ground in 30 Doradus, located in the heart of the Tarantula Nebula. Early astronomers nicknamed the tarantula because its glowing filaments resembled spider legs. 30 Doradus is the home to the most massive stars ever seen, weighing more than 100 times the mass of our Sun. No known star-forming region in our galaxy is as large or as prolific as 30 Doradus. The image reveals the stages of star birth from embryonic stars a few thousand years old, still wrapped in their eggs, to behemoths that die young in supernova explosions. Hodge 301, seen in the lower right-hand corner of this image, lies inside the Tarantula Nebula. Many of the stars in Hodge 301 are so old that they have exploded as supernovae. These exploded stars are blasting material into the surrounding region at speeds of almost 200 miles per second. The high-speed matter is plowing into the surrounding Tarantula Nebula, shocking and compressing the gas into a multitude of sheets and filaments seen in the upper left portion of the picture. A unique peanut-shaped reflection nebula surrounds a cluster of young hot stars in this view from Hubble. The double bubble, N30b, is inside a larger nebula. The very bright star at the top of the picture illuminates the dusty cocoon like a flashlight shining on smoke particles. This searing supergiant star is only 25 light years from the N30b nebula. swirls of gas and dust reside in this region of star formation. It reveals a region where low-mass infant stars and their much more massive stellar neighbors reside. This is just one of the hundreds of star-forming systems located in the LMC. This region is a firestorm of raw stellar creation, perhaps triggered by a nearby supernova explosion. The three-dimensional looking image reveals dramatic ridges and valleys of dust, serpent-head pillars of creation, and gaseous filaments glowing fiercely under torrential ultraviolet radiation. The region is on the edge of a dark molecular cloud that is an incubator for the birth of new stars. Now let's take a look at a couple of objects in the Small Magellanic Cloud. At the heart of the SMC lies cluster NGC 602. The high-energy radiation blasting out from the young stars is sculpting the inner edge of the outer portions of the nebula, slowly eroding it away and eating into the material beyond. Elephant trunk-like dust pillars point towards the hot blue stars and are all telltale signs of their eroding effect. The NGC 346 cluster at the center of this Hubble image is resolved into at least 3 subclusters and collectively contains dozens of hot, blue, high-mass stars, more than half the known high-mass stars in the entire SMC. A myriad of smaller, compact clusters is also visible throughout the region. Here are the local group galaxies we saw in this segment. The local group is part of a larger structure known as the local volume. We'll explore this local volume in our next segment.